All right, Luke, welcome to Lesson 35, Part 2. So today we're going to be talking about the second part of the Lesson 35. We kind of split this up because it was getting to be a longer lesson, and I want to make sure that I don't give you too much at once. So let's go ahead and get started. All right, well, let's move on now, and we'll talk about canceling. Okay? Um, let's take a look at this problem here. 3b divided by 3. This should look familiar because we see this a lot in equations, and we should already know how to deal with this problem. But just for the sake of the argument here, let's go through it. So a 3b over 3, we know that we can cross out the two 3's, right? The 3, in a sense, cancels out the 3 in the denominator, right? Now, why is this? And the answer is, the long answer is that if we take 3b over 3b, we could rewrite that as 3 over 3 times a b. All right? Now, hopefully you can see that. All I did was split this numerator up. The 3b, I split that up into a 3 over 3 times the b, right? And we can clearly see that if we were to multiply this out, we'd have to place the b over a 1 so that we have fractions, and then multiply the numerators, and that would give us 3b, multiply the denominators, and that gives us a 3. So clearly we're not changing anything by writing it as 3 over 3 times a b. But the advantage to writing it like this is it becomes very clear that 3 over 3 reduces to 1, right? So this is equivalent to 1 times a b over a 1, if you will. And 1 times b over 1 is just simply going to be a b, right? So therefore, it kind of makes sense that we can just cross these 3's out, and we're left with the b. The 3's kind of reduce to 1. They cancel out, okay? And we're left with the b. Okay, so that's just kind of the long explanation as to why we have been able to just cross these 3's out when we've found them in equations and such. But now compare that to the problem over here. Over here we have the problem a plus b over a. And the temptation might be to say that this is somehow similar to this problem over here, in that we could write it as a over a plus b, kind of breaking up that numerator in the same way that I broke up the numerator over here. But in fact, this is not true. This does not equal, a plus b over a does not equal a over a plus b. Okay, and if you doubt me, well, let's go right ahead and try to add this here and see what happens. So if I add this, I would have to place the b over a 1, right? So we have fractions. A over a plus b over 1. Well, in order to add fractions, I need to have a common denominator, right? So the common denominator here is going to be the denominator a, right? Okay, and this fraction, I didn't do anything. I multiplied the denominator by 1 to get this a, so I have to multiply the numerator by 1. I still end up with an a. In the other fraction, I'd have, again, my plus sign. I had to multiply this denominator by an a to get this a, so I have to multiply the numerator by an a, and this would be a b, correct? Now, this does not match our original problem. You may think it's close, but no, it doesn't match. A plus b over a is not equivalent to a plus ab over a. So that leads us to believe that this is incorrect. This is not right. And that is something that I really want you to remember, because it is a very common mistake that a lot of algebra students make. When we have addition in the numerator, we cannot, I repeat, cannot cancel out between the numerator and the denominator. It simply will not work. All right. And the reason is because it's not multiplication. Over here, when it's multiplication, we were able to split that numerator up and not affect our work, our answer. But over here, we cannot. We can't split that numerator up and then, divide out the a. Okay? So, long story short, when you have multiplication in the numerator and you have a common factor in the numerator and in the denominator, such as the 3's here, you can cross those out. If you have addition in the numerator, but, let's just say if you have addition in the numerator, you can't take one of those add-ins and cross-cancel that out with a factor in the denominator. All right. And the reason behind that, too, is that here we're splitting that numerator up into factors. We're splitting it up into a 3 times a b. Those would be 2 factors. Here, we're not splitting it up into factors. There's no multiplication in a plus b. And since there's no multiplication, we can't have factors, right? Because factors implies multiplication. So there's no multiplication going on, so we can't say that there's a common factor in the numerator and in the denominator that we can cross out, at least not in this case. All right, there is no let me say that again, because that's very important. There is no common factor. Think about what that means. A common factor in the numerator and in the denominator. There is no common factor. There's no number that is being multiplied in the numerator as well as being multiplied in the denominator. That is true over here. We do have a common factor. It's a 3. The 3 is being multiplied in the numerator, and the 3 is being multiplied in the denominator. Okay? So hopefully you see how that works. This one, we cannot simplify it. That's as simplified as it'll go. And then over here, we could simplify it. All right, so let's take a look at this next problem here and hopefully kind of iron this out a little. So if I have a problem that looks like this, I have 3 times a parenthesis a plus b, ending parenthesis, divided by 3. Okay, the question is there something that I can cancel out? Is there something that can reduce down to 1 here, like we did up in this first problem? All right, so think about that for a second. Is there something that we can cross-cancel or cancel out in this particular expression? And if you think about it, there actually is. In this case, we can cross out that 3. And you might say, well, whoa, wait a minute. We've got addition in here. So doesn't that mean we can't? Well, the 3 isn't being added. The 3 is being multiplied. The 3 is being multiplied by the a plus b. So the 3 is a factor in the numerator. Okay? It's a factor in the numerator. It's also a factor in the denominator. If you want, you could think of this as, a 3 times 1, and thus making this 3 a factor. So 3 is a factor in the numerator as well as in the denominator. Therefore, we can cross it out. And we're left with an a plus b over 1, which is just simply an a plus b. Right? See that? All right. Let's take a look at this one over here. What if I have 3 plus c over 3? Can I factor anything out of the numerator and the denominator? Can I cancel, I should say. Can I cancel out anything in the numerator and the denominator? Think about that. Well, in this problem, the answer is no, I cannot. And the reason I cannot is because there is no factor in this numerator that I can pull out. All right? There's a 3 and there's a c, and they're being added to each other. So because there's no multiplication going on up here, I have no chance of being able to cancel out anything in the denominator. All right? There are 3's here, but this first 3, this top 3, this is not a factor. You might say this is an addend, not a factor. All right? This one you could argue is a factor if I multiply it by 1, but that is beside the point. They both need to be factors. Okay? This one's being added. This one is not. All right? So that one, no, I'm done. The answer is right here. There's nothing else that I can do to simplify that. Now over here, this is an interesting one. Look at this closely and decide if there's something to cancel out. All right. So remember, we're looking for factors. And also, remember, we discussed earlier thinking of parentheses as containers. All right. They contain things inside, but the set of parentheses can be thought of as kind of a single unit. All right. One bucket just containing a bunch of stuff. All right. So let's take a look at this numerator. We do have multiplication going on in the numerator. We're taking this 3 and we are multiplying it by something. We're actually multiplying it by these parentheses, right? So you might say this 3 is, well, maybe I'll reverse that. This 3 is factor number 1, Maybe if we just clarify, it's factor number 1, okay? Well, if that's a factor, it means it's being multiplied by something. So what is it being multiplied in this case? It's being multiplied by the parentheses. So this whole set of parentheses is actually, you might say, the factor 2, the second factor. All right, factor 1 is being multiplied by factor 2. And factor 2 is this set of parentheses. It's this bucket. All right, now there are multiple things inside this bucket, and there is addition going on in here, but this set of parentheses, the whole thing is being multiplied by a 3. So this whole thing can be thought of as a factor. Okay? Hopefully you understand that. Now looking in the denominator here, we could then take this a plus b in the denominator, and is there anything wrong with me throwing parentheses around that? No. That's totally fine. There's nothing wrong with that. I can throw parentheses. That's not going to change the value of it in this case. And if I do that, it becomes a little bit clearer that I have the same bucket on top as I do on bottom. And this bucket, the set of parentheses on top, is being multiplied by the 3. This bucket down here, you might say, is being multiplied by a 1. That wouldn't change anything. And there we can see then that we have actually two factors that can be canceled out. We have this bucket, this set of parentheses that we can eliminate, reduce to 1 in the numerator and the denominator. Okay, so they in fact can cancel out, and they will give us a 3. The whole thing would then give us a 3 over 1, which is just a 3. Okay, so that would be our final answer to this fraction. And hopefully that kind of makes sense. So there are multiple ways that we can show factors, and one way is to show it as a set of parentheses here, and that can get canceled out if there's the same set of parentheses in the denominator. Otherwise, we have just numbers that can be canceled. All right. I suppose we could even do one more and just say, if I have something that looks like this, 5k over a k, we can recognize that this is multiplication. These k's can cross out, and we're left with a 5. So we can cross out variables. Variables, numbers, or even full expressions if they're the same. The same bucket of expressions. Okay. All right, very good. So let's just try a couple of these and see how you do. Here, this first one, let's do this together. So we have 3a squared plus 12b squared over 3. And the directions might tell us to simplify in this case. And if we look at it, there's nothing that we can add in the numerator. There aren't any like terms that we can combine. Obviously, there's nothing we can do in the denominator. So the next thing would be, is there anything that we can do to reduce? And you might notice that this one has this addition sign in here, okay? And so this term is being added to this term. And you might say, well, okay, we have addition. We can't do anything. True, but what if we take what we've learned in the first part of this lesson and try to take this numerator and factor out the greatest common factor and see what happens? All right, so let's start with that. Let's factor out the greatest common factor. So we have a 3 and we have a 12. Those are the numbers. What would be the greatest common factor between those two? Well, it would be a 3, right? The greatest number that can go into both. All right. Then we have an a. This is an a here. We do not have an a here, so that is not a common factor. And we've used up everything in the first term. So the only common factor between these two terms is a 3. All right. So then remember, we have to put our bucket together here. All of our leftovers go into the bucket. So we have this 3a squared. If we divide out the 3 here, so take the 3a squared, and this is what you should be doing in your head, but you're taking the 3a squared and you're dividing it by this greatest common factor, this 3. 3's cross out, and we have an a squared left over, so he goes inside of our bucket. And then we have our plus sign, and if we take this second term, 12b squared, and we divide it by this 3, we'd end up with 4b squared, correct? And if you're unsure, just do a quick check. Just distribute this back through. 3 times a squared is in fact 3a squared. 3 times a positive 4b squared is in fact a positive 12b squared. So we know we factored it out correctly. Okay. So now we have this expression in the numerator over this 3 still. We haven't touched him. And lo and behold, now hopefully you can recognize that we do have multiplication in the numerator. We have this 3 that's being multiplied by this set of parentheses, right? And lo and behold, we have a 3 in the denominator. So we can now cancel out these 3's. All right? And now we end up with a much nicer expression. We don't even have a fraction anymore. It's simply a squared plus 4b squared. Okay? So we took this rather, relatively nasty looking fraction, and we were able to just simply reduce it, simplify it to a much nicer expression over here. Isn't that great? So that's what you're going to be trying to do, is try to factor out the greatest common factor and then see if there's any reducing, any canceling that you can do within the fraction. All right? So why don't you take this next one, try it by yourself, and then we'll do it together. All right, so let's give this one a whirl. So let's start by finding our greatest common factor in the numerator. And our numbers are a 4 and a 2. So the greatest common factor there is going to be a 2. Then we have an a to the third, and there is no shared variable. So that's it. It's just the 2. Okay, it's the only thing we have for the greatest common factor. So now we put in our leftovers. We have a 4a to the third term. Well, if we divide that by the 2, we end up with 2a to the third. Then we have a plus, and we have this 2c to the third. If we divide that by 2, we're just left with 1c to the third, which of course is just c to the third. So that's what's left over inside our parentheses. And now we can put our denominator back in place here. We have our 2c. We haven't touched that. And we can look for something to cancel. And in this case, hooray, we do. We have a 2. So the 2 can cross cancel out in the numerator and the denominator. And we're left with a final expression. And I can actually remove the parentheses now because the multiplication has disappeared. And we have 2a to the third plus c to the third all over a c. So it didn't reduce down quite as nicely as the first one, but hey, it did reduce down somewhat. Our numbers are a little bit smaller. We don't have a 2c. We now only have a c in the denominator, and that could be very helpful. All right? Excellent. All right, let's try this one. Go ahead and pause the video. Give this one a try. All right, so again, finding the greatest common factor in the numerator is where we will start. And for the numbers, we have a 5 and a 30. Greatest common factor will be a 5. And then we have, for the letters, we have a c here. And this one actually does have a c over in the other term. So it is a common factor. And they're both to the first power. So we have c to the 1. And then we're out of components over here on this first term. So that's as far as we can go. So we're ready to put our leftovers in place. So the 5c, now be careful with this one. All right? We don't just say, oh, we have a 5c here, so they're going to eliminate this 5c. Remember, we're dividing. So we take this term and we're dividing it by our greatest common factor. So 5c divided by 5c is in fact 1, right? So we do have to put the 1. It's very common to just forget to put that 1 there. But we do have to put the 1 because that is being added to our next term. All right, so we can't just eliminate it. The 5c, or actually I should say the 5c divided by the 5c is going to give us a 1. Okay, then we have our plus sign, and then we have this 30cx squared divided by 5c. Well, the 30 divided by the 5 is going to give us a 6, right? And then the c divided by this c, well, again, it's c1 divided by c1 is just going to give us a 1, right? So in this case, you don't necessarily have to write it now because, I mean, this is just 6 times that 1, right? And I know that's just going to be 6. So in this case, I'll leave it as just the 6. I'm just kind of thinking ahead. And then I have this x squared left over still, so that's going to be here. And again, if you want to double check these, it's never a bad idea just to make sure that you factored that out correctly. If I take this 5c and multiply it through by this 1, that would give me 5c. So there's our first term. And then 5c times the positive 6x squared. Well, 5 times 6 is 30. And then c times x squared is in fact cx squared. So it does work out. We can work it backwards to where we started. Okay, and then in our denominator, we have the 5cx still. We haven't touched that. And now we can look to see if there's anything that we can cancel out. And looking at this, we see again that this is multiplication. So 5c is a factor up in the numerator. It's also a factor in the denominator, right? 5c is being multiplied by the x, so it is a factor in the denominator. So we could say that the 5 would cancel out the 5, and the c is going to cancel out the c. And then we'll be left with just the parentheses, which will be 1 plus 6x squared, all over our denominator now is an x. All right? And that is going to be our answer. All right? And again, just as a point here, notice this x cannot cross-cancel one of these x's out, because these x's are a factor to the 6, it is true. So you could argue that these x's are a factor, but they have to be a common factor of or for everything in the numerator in order to cancel it in the denominator. And this x squared is a factor with the 6, but it's not a factor with the 1. It's not being multiplied by the 1. And the only time we can cancel things out is if this x were a factor of every term in the numerator, not just one. Notice that over here, this 5c was a factor for everything. It's being multiplied by this set of parentheses right here, and that's all that's left in that numerator. So it is being multiplied by everything in the numerator. That's why we're able to cancel it out in the denominator. Okay? All right, so let's try this next one. Pause the video and give it a try. All right, so let's see how you did here. We've got 6xyz. All right, so let's factor this out. So we have our numbers, a 3 and a 6. Greatest common factor would be a 3. And then we have an x and an x. They both have x's. So we know we're going to have at least one x, and that is, in fact, our lowest power here. So we're just going to keep the 1x. Then we have a y, and we have a y. They both have y's, and again, it's just a single y. And then a z, well, they don't both have z's, so that's going to be included in our leftovers. Okay, so now let's put our leftovers together here. We have a 6 divided by 3, which is going to give us a 2. We have an x, y, and z. Well, the x divided by the x is going to be a 1. The y divided by a y is going to be a 1. And the z is left over, so we end up with just 2z, or 2 times 1 times 1 times z, which is just 2z, right? Then we have our minus sign. And now we have a 3x squared y squared divided by 3xy. Well, the 3 divided by the 3 is going to be a 1. Maybe I'll even just put that in this case. I'll put the 1. And then we have x squared divided by an x. Well, that's going to give me an x. And a y squared divided by a y. Well, that's going to give me a y. Right? So I have 1xy. So I could eliminate that 1 if I wanted to write this a little nicer. But it's fine that it's there. All right, now we divide out, and we've got a 3 and x squared in the denominator. Okay, so again, we have multiplication. This is being multiplied by everything. So we can cross cancel if we have common factors in the numerator and the denominator. So the 3's are common. We can cross those out. Now this x, we only have 1 up here, and we have 2 being multiplied down here. So this x would eliminate one of these x's. Not both, but one of them. So this would just become x to the 1. So I'll just cross out this 2. We still have 1x left over, right? And that would mean that our final answer here is going to be the y times the 2z minus the xy all over just an x. That's all that we have left. All right? And that would be our solution. All right? So hopefully these are making sense and you're getting better as you practice these. They do take a little bit of practice, just so that you can kind of get the hang of it, but it's not too complicated. As you do more of them, it'll become a lot easier. All right, so I think we're going to stop here for today, but just as a real quick recap, because this was a pretty important lesson here. What did we do today? Well, we learned how to factor out the greatest common factor, right? And how did we do that? We first decided what the greatest common factor is, and then we factored out the greatest common factor from all of the terms. So we pulled it out from all of the terms, and then we placed the leftovers in a set of parentheses as the second factor, right? So, yeah, remember we found the greatest common factor, and then we set next to that the parentheses, and then this is our leftovers after we've divided everything by the greatest common factor, right? And then we learned how to cancel. And really the thing that you need to remember here is that only common factors can be canceled from the numerator and the denominator. And these common factors must be common to all the terms in the division problem, right? So essentially what that's saying is I cannot cancel out the 3 here because it is not a factor for every term in this numerator. I cannot cancel this out. This is a big no-no. No, does not work, okay? Because again, the 3 is not a factor for every term in the numerator. You might say that, like this, on the other hand, I can cancel out because 3 is a factor of everything. It's a factor for everything in the numerator. This 3 is being multiplied by the x. It is being multiplied by the 2. So it is being multiplied. It is a factor for everything in the numerator. It's also a factor for everything in the denominator. It just happens to be by itself. All right? So they can cross out. They can cancel. This cannot. This can. Okay? So hopefully we're very clear on that point. That's a very common mistake. All right? Very good. Well, we will stop here, and we will pick up tomorrow. Good luck with your seat work.